A swarm of 120 fruit flies in an experiment grows at a rate of about 9.8% per day. Part A. Find an equation for a model for the number of fruit flies in the swarm. Whenever we see a growth rate, or if we see a rate of decay, right, if we're told it's increasing or decreasing by a rate, what we can use as our base is, if it's growth, 1 plus the rate, right, that's for growth. If it's for decay, we would use 1 minus the rate. So, for this example, we're asked to find an equation for a model for the number of fruit flies in the swarm. What we could start with is, well, we have our regular, let's define our variables first. So let's call D the number of days, and let's call F of D the number of flies in the swarm. And so my goal here is to write, since we have that growth rate as a percentage, that clues us into an exponential function. Whenever we see a growth or a decay rate, when you see something like that, that clues you into use an exponential model. So I'm going to write F of D is equal to A times B to the D. Now, since we have an initial number of fruit flies, a swarm of 120 fruit flies, we know that the A value is 120. We have a growth rate of 9.8% per day. Then the B value would be 1 plus 0.098. We must write that percentage in its decimal form. And so that's 1.098. So then we can write the model F of D is equal to 120 by 1.098 to the D. Part B asks us to estimate the number of fruit flies in the swarm after 20 days. So after 20 days, that lets us know that D is 20. So then we would evaluate F of 20, which is 120 by 1.098 to the 20th power. Bring up the calculator. 120 by 1.098, raise that to the 20th power, and it's approximately 778. So my conclusion, after 20 days, the swarm has about 778 flies.